This is a question about finding the empirical formula, which is the ratio of atoms to each other. So the empirical formula of CO2 equals 1 to 2. So it will be C1O2 as an empirical formula. It's the ratio of the atoms to each other in an atom. Now, in this question, we have been told that there was 0.6 in this compound, 0.6 grams of carbon, 0.15 grams of hydrogen, and 0.4 grams of oxygen. Now, because the relative atomic masses of each of the atoms is different, it's not just a ratio as we see it there. And what we have to do is, step one is to turn them into moles to see the molar ratios. So we have got 0.6 grams of carbon, we have got 0.15 grams of hydrogen, and we've got 0.40 grams of oxygen. Now, carbon has a mass number of 12, hydrogen has a mass number of 1, and oxygen has a mass number of 16. So we can see that if we want to get moles, we divide 0.6 by 12, which gives us the number of moles of carbon. So 0.6 divided by 12 is 0.05 moles. We've got 0.15 divided by 1, which equals 0.15 moles of hydrogen. And we've got 0.4 divided by 16 moles of oxygen, which equals let's do the 0.4 over 16, because that's the mass number, which equals 0.025. So they are our molar ratios of there. So these are the moles. So there's 0.05 of moles of carbon, 0.15 of hydrogen, and 0.025 of oxygen. And then what we need to do is we need to decide which is the least. Which is the least of these in order to decide what to do next. And the least here is this one. It is the 0.025. And we then find out how many times that will go into the others. And so if you do 0.05, the carbon, divided by 0.025, you get 2. So our empirical formula is going to be C2. The next one, for the hydrogen, you do 0.15 divided by 0.025 for your hydrogen, which equals so we've got 0.15 divided by 0.025 equals 6. So there's going to be 6 hydrogen, so it's going to be H6. And the oxygen is our lowest one, so it would be technically 0.025 over 0.025, which equals 1. So the empirical formula is 2 carbons to 6 hydrogens to 1 oxygen, and so it would look like this: C2H6O. And that is the empirical formula as discovered by finding the molar ratios from the masses that they've given you and then calculating it on. Now, there's another way that you could do this. Instead of just finding the lowest one here of 0.025, they are quite cumbersome, those figures. So you could multiply all of them by 100 and divide by the smallest one. And then what would have happened there is you'd have got 2.5 for the oxygen here, and you'd have got 15 and 5, and then that would have given you the same division and the same empirical formula. But you can, as long as you can identify the smallest one, you just divide by the lowest common denominator, which is 0.025 in this case for the oxygen. So that's how you work out the empirical formula of a compound based upon being given the masses.